Friends, today I am going to discuss eigenvalue problems. So, what is the eigenvalue problem? So, like if I am going to talk about like a special system of equation, and this is a great theoretical and practical importance. It is an eigen equation like ax will equal to lambda x. So, if I write ax will equal to lambda x, where A is n cross n square matrices and x is an unknown vector. So let's see here unknown vector. So the lambda is the unknown scalar. So here x is an eigen vector and lambda is eigen of the matrix A. So the eigen equations will equal to like a ax will equal to lambda x closely resembles and the linear equation systems like a ax will equal to b. But note that here the both x and lambda are unknown. So we cannot directly apply the same technique to solve a equation. A standard approach to solve this eigenvalue problem is to rewrite the equations as bracket start a minus I lambda x will equal to 0, and note that there is a exactly non-trivial solution like a x will equal to 0 matrix a minus I lambda must be singular, so its determinant must be a 0. Here you can also write a det means determinant parenthesis a minus I identity matrix lambda will equal to 0. It gives the polynomial equation just we have already discussed in the previous section. So of the nth order whose nth roots gives n eigen values like a you can say just how do you say, yeah, lambda n, it represent like a n will equal to 1 to tell n. So once the eigenvalue is known, the equations like A minus identity matrix and lambda n and whole cross these inside of the bracket and xn will equal to 0 can be solved nth eigenvector xn and using a standard forward substitutions. So how to solve? First we need to understand like a simply we are already applying this to both the simply and like a simply pi and the linear algebra. So I will try to like this eigen and eigenvectors methods of the matrices class, so which are the able to the write the some codes. So let's try. So let's try here. So I am going to write here e anything like a EPS and like a delta will equal to simply s y m py simply dot symbols dot s y m b o l s and parenthesis you can write like a anything like epsilon comma delta. Let's see. And next another I am going to create a another variable like h will equal to something like a simply dot matrix simply dot matrix parenthesis this, and we can write like EPS dot delta and like the another bracket comma delta and minus EPS, right? And then we go here like a print H, like H. So I hope you can see something look like output here. So simply matrix delta. So yeah, it has been printed look like this. Now I am going to write here H eigens. So here, because epsilons and delta it represent like a first row, epsilon delta another row, delta and minus epsilons. H dot eigen EIGEN eigenvalues and another is the eigenvector. So I am going to eigenvalues. So let's see. So H delta eigen, H I have already created a variable. So look here, this one it should be like a inside of this bracket, but don't need. Okay. And similarly I am going to do like a eigenvector. So H dot eigenvectors. So eigenvalue I have gotten, and now I am going to get eigenvector. So let's see. Yeah, it is look. I think what is this? Yeah. So this is a eigenvector like this. Yeah, it's great. It contains the only one. It contains the first and second. Here it contains only one. It contains the first and second rows. So look here. So the return value of the eigenvalues method is a dictionary where each eigenvalue is a key and the corresponding value is a multiplicity of that particular eigenvalue. So here the eigenvalue are like a first minus a square root delta square plus epsilon square and comma 1, means there it has a 2 column, it has 2 rows. Okay, so here the eigenvalue this and this like a minus epsilon square plus delta square and epsilon square and square root and epsilon square and delta square, each with the multiplications 1, and the return value of the eigen is a bit more involved, a list of return where each element is a tuple containing an eigenvalue. So the multiplicity of the eigenvalue and list of eigenvectors. So the number of the eigenvectors for each eigenvalue equal the multiplicity of the current example. So we can unpack the value returned by the eigenvectors and verify the two eigenvectors are orthogonal using like a something. So let's try to something like I am going to write EV like a EVAL I have already taken, so look here 1 comma like this 1 comma EVEC1 VEC1. Inside of this parenthesis let's write the another as EVAL2 EVAL2 and parenthesis EVEC2 EVEC3 EVEC 2, and this will equal to like H dot eigenvalue EIG. So no, I need to write here eigenvector EI eigenvectors, and we will put here parentheses. Now you can use the simply here. So let's see the simply SYMPY dot simplify parenthesis EVE C2 EVE C1 square brackets 0 dot P and EVEC 2 square bracket now 0. So let's see what is the output here, because it has been evaluated. Yeah, we have gotten here, I have gotten here 0. So obtaining an analytical expressions for a eigenvalue and eigenvector using these methods is often a very desirable indeed. So but unfortunately it only works for small matrices. For anything larger than 3 into 3 matrices, the analytical expressions typically becomes an extremely lengthy and to work with even using the computational algebra system like a simply. Okay, so I think this approach is very helpful for everyone. Just try to create a new matrices, like the matrices science pi linear algebra package. So just try here, and then we try to solve here. Like first I can create a matrices like A will equal to look like this, and then I write here evals this comma EVECS will equal to LA dot EIG parenthesis capital A. And now we can print one by one EVALS, and we can see your output. And similarly if I write here EVECS. Okay, so let's see, this one is the EVECS. So let's try. You can write here, this one is here, but don't write there, don't write here. You can write EVELS here and write EVEC has been printed here. Now I am going to write there LA dot eigen flash and parenthesis look like a capital A. So I think you have gotten like this. So this is a value, and since the matrices in an example is a symmetric, so we could use like a LA dot eigen EIGH and LA dot EIG values, giving the real value eigenvalue arrays, and we have gotten the output like this. So these are the basic. I think it will be the helpful for everyone, and how to write the eigenvalue code with the linear algebra. Thank you.